Yo yo yo, good morning slash good evening. What's up by me? Okay. So the goal for today is to see if I can manage to put the fluid solver calculations on a separate thread, and I don't want to take the full algorithm and just execute it from start to finish on a second thread. We want to add, like, splitting it up, looping through one of the steps more times before we move on to the next, and things like that. And I also want to be able to kill that thread or cancel it in a nice way. So let's see. Or the idea more specifically is that we're gonna run, let's see, here, and if we add water here, we're gonna start the thread, we're gonna let it iterate in different ways, and exit. Let's see here. I thought we had the process for the terraforming in place. Maybe I need to oh yeah, we do. Do you have a fluid object to live mesh thing yet? Yeah, we have that in place, but we're waiting with that one right now. I thought, let's see. Action terraform. Yeah, we just want to wait with this one, right? Yeah. Waiting, question mark. Yeah, we're gonna wait. I want to get this in place first before we move on to the mesh. I want to make sure that this works, handle every edge case, etc, etc. So it's on the back burner. Ooh. Okay. Yeah, this flow is gonna look a little bit weird for now, but all the terrain data, apply terraform brush. Oh, how do I want to do this? So around this point, and water terraforming is it differs a little bit as opposed to the other terraforming we have in place right now, because this one will always only affect the initial effect will only be on one point, one cell, as opposed to like ground terraforming, which terraforms an area. So I wonder, do I actually... I'm me. Okay, a quick catch up. What's the system supposed to do exactly? Question mark. Water moves from a cell to another cell with some kind of physics push-pull. No physics at all. Some weeks it looks the same. Yeah, I haven't been able to work that much. So, but we have still made some nice progress. So no physics, we just want to fill an area in a nice way, a fun way. So be able to terraform, add water. So we pretty much have 3 iterations in the algorithm. I've gone through this multiple times, you can see it in the other videos, but first we find minimas in the terrain, so where water can pool up or where water should pool up. Then in the second iteration we find out how much water pools up at those points, and at the third iteration we fill it. If terraforming the terrain, water should respond, I guess. Yes, but it's gonna respond in a very easy way. So like I've also said this multiple times, if we terraform next to a lake, for instance, if we lower the ground next to a lake, that lowered ground will just be filled with water. The pool of water we already have will not lose water. One sec. Okay, back. Do you capture water pools like they are individual? No. It's all behind the scenes. It's just textures keeping data pretty much in a grid. So we know how much water each cell in the terrain holds. Let me see. I want to see if I can visualize an example here with my nice drawing skills. Okay. Yeah, worst case scenario, we can it's gonna be covering quite a big area. Okay, let's see if I can visualize this in 2D in a nice way. So if we have terrain like... Fuck, I wonder if we can do a worst case here. How do I want to visualize this? Something like this maybe. And then the player goes here. And pulls out the hose and start filling this point with water. We're gonna offload that to a second thread. This thread is first going to calculate, it's going to find, so we have an initial amount we spray out, and with that initial amount we're gonna flood fill the area, but for every step we lose fluid, so we're gonna see if we find a minima. And once again, a minima is a point in the terrain where all the neighbors is the same height or bigger, and at least one of them is bigger. So we're gonna, based on the initial amount, we're gonna walk or flood fill. If we don't find a minima, we're gonna increase the amount, so we disperse at a bigger area. If we don't find a minima, then we're gonna increase the amount again, and we're gonna do this incremental until we find a point. And that's like the first step, and it's planned to be like this because when you fill up something with water, you want to be at the point where water is going to pool up, otherwise it's going to take a little bit longer, but that's okay. So when we find that point, the minima, we're gonna add the initial filter. One sec, sorry. Okay, back. Sorry about that. Let's see if I can continue this explanation. I think it will shed some light. So at this point we have a minima, and what we do then is that we add the initial fluid amount to the minima, and we spread it, and we want to spread it in such a way that it doesn't overflow. So we flood fill and we check if the water dries up in any direction. That means that we walk in parallel and get to a water amount of 0. Then we increase the fluid amount and do it again. But if it doesn't dry up, then we fill it and then we visualize it. So at this point we have a little bit of a small pool of water. The algorithm itself continues, so after we have filled it, it increases the amount, and we do the same process again. We're gonna be able to walk here, then we increase it again, do it again, and at that point we're probably gonna get to a state that looks like this, maybe. And what happens here is that the water dries up here, so we get, if we add this amount to the minima, we're gonna overflow and we're gonna dry up. So that won't work. We will get data from it, but when we do the final fill, we will fill it with less water because we don't want to overflow. But if the player doesn't exit the adding of water, we're going to do the calculation again. And if we have a little bit of a more water, maybe we will get something like this, which doesn't dry up. Then we have the next stable state. And like we're just going to iterate like this, add more and more and more and more water until the player exits. So yeah. So I'm me, but are you doing this across the entire map? Like it depends. Also, like worst case would be across the entire map. So if we have a case where the entire map is just a flat plane, if it's just a flat plane and we start adding water, the first iteration is not going to find a minima, the second one isn't going to find a minima, and it's going to continue like that forever, or until the player exits, because we won't be able to add water. So we're working on player volume in the water. So you're working on player volume in the water. I don't know what you mean by that. Like the player is just the influx here. The player is irrelevant. Like the player chooses the point and starts the influx. Then the algorithm will iterate until the player quits. That's the idea. So, yeah. But you just said it's about volume in the water. Like it is volume of water, but it's very simplified. So each cell is delta times amount of water. So we always have, like we have simplified it so that we only measure volume in one dimension. We don't care about x and y. And it's not as much as about displacement, because we don't displace water, we spread water. And when we spread water, the initial cell doesn't lose volume, so it's not really displacement in that sense. It's more about spread without loss of initial volume. My question about your statement, so you're working on player volume in water, was more on the focus of player. I don't really understand the player part. And so then basically Minecraft water can expand on very large scales. That's a problem for water-related algorithm. There is quite nothing to do about it. That is pretty much my understanding as well. Like, worst case scenario is always going to be the full area of the map, and then how different algorithms solves that problem, yeah, it's up to them. Like, we're gonna offload the work to a second thread. That thread can run indefinitely if the player chooses to, but unless it finds a stable state, the end result is going to be nothing. I mean, in video games everything is a trick. That is true, and this is one hell of a trick we have converged to here. I think we have, like, the solution we have now is going to be, it's going to be quite straightforward to create pools of water, even with rivers and such. And like, if the player tries to fill up a big area, it's going to take longer time. But we're offloading it to a second thread, we're gonna hide it behind some animations, and it makes sense. So right now we're just in the part of, like, we have the algorithm in place, all of the steps work. We have some edge cases that are still question marks, but yeah. Now I'm just trying to separate it in such a way that we can utilize a thread for it. So once again, terrain fluid solver. First step, find the minima. I don't know, keep the questions coming. I want this to be as clear as possible, and like, you and the other viewers will most likely find faults in this. So like, I want this to be peer reviewed, basically. But like, the very core, or the very core of this algorithm is just a simple flood fill, right? We take a point, we spread the fluid to all of its neighbors, and then if we succeed in spreading the fluid to the neighbors, we add them to unvisited points, and that's pretty much, we do this until we can't spread no more. That's like the first iteration of the algorithm, but the most important part is this one. If it doesn't have any lower neighbors and it has a higher neighbor, then it's a minima. So right now we exit if we find one minima. This is optional. Previously we have continued and found multiple, but right now we exit at the first minima. And like, this part, this is the core of the algorithm. We do this in all of the 3 steps, but what we calculate from this are different parameters we'll later use to finally fill it up. Yo, what's up, modding Minecraft? Still water physics. Yeah, water quote-unquote physics. So first step, flood fill to find the minimas. Second step, flood fill to find new fluid amount, basically. And we do it based on if we dry up in parallel, or if we find a new lowest unreachable height. And then we have the third step, also flood fill. But here we do the final spread. The difference between all of these flood fills are the parameters here. So like costs for moving in parallel, up and down. We have different ones for all of these. And we also handle the result of this one differently. We had it visual, like we had it rendered in a visual way previously, because we had all of this in a coroutine that spawned blocks for every single step. I think it gave a pretty good view of what the algorithm is actually doing. But now we have stripped it from all of that because we wanted to do some timing, like see how long time it takes and stuff like that. And are all these called linear single thread? Yes. Right now, up to now, we have made this on the main thread, and it was surprisingly quick, but not quick enough. So the idea now is that This call is going to be, we're gonna have a second thread that does this call, and we're gonna loop through this one, this part of the algorithm, until we find a minima. So we loop through this once. If we haven't found a minima, we increase start fluid amount. We loop through it again, and we do that until we have found a minima. At that point we have a minima, so we loop through this one with the minimum amount of start fluid amount, and we do the same thing here, like fill it up, get new final fluid amount, repeat, fill it up, get new fluid amount, repeat, repeat, repeat until the player exits. Then we know what fluid amount we can fill up the area with, and that's when we move to the final step and actually fill the area. What's Unity called multi-threading? Shit, I have no idea, but I think we're gonna do it with, I think the go-to is the default C# here. It's a good question. Like, if I'm gonna be honest with you, yeah, if I'm gonna be honest with you, like, my experience with threading is limited, and my experience with threading in C#, or more specifically Unity, is close to zero. Like in Unity and C#, I've done very small things, but I know the usual pitfalls of threading or multi-threading, and we're gonna avoid those. I don't think so. Like, we're only gonna alter local variables, so we're not gonna alter the scopes of the variables we alter are gonna be local, so we don't have to worry about like racing. We're only gonna have one thread. So we're gonna have the main thread and this new thread we create, and the communication between them is going to be extremely limited, and the main thread is going to be the main, so it's going to have precedence. So like, we're never going to get in a situation where we have a deadlock or anything like that. Like, we're just going to offload work to a second thread and read the result from that when it's done, pretty much. Yo, what's up, Lago? Which dev? You probably need to use C# system threading. Yeah, that's what we when we started looking at it yesterday, that's what we thought as well. I have a lot of experience in threading. Nice, then maybe you can point me in the right direction here if you see me do anything that is fucked up outside of Unity. Yeah. Yeah, Unity has the burst compiler that should somehow allow to compile blocks of code. Burst compiler, or like burst related, and what is it, the entity system in Unity, I also have very limited experience with. But right now we're just gonna do very simple threading here. And so there are coroutines for Unity's threading, but this is for CPU. I haven't had any experience with GPU programming. So yeah, right now we're solely doing this algorithm on the CPU. Parts of it might be moved to the GPU later, but right now only CPU. Yeah. So yeah, coroutines are run on the thread they are called from, yes. So let's see what Unity official manual does. And let's go to my version, even though it's not an LTS, I don't think. Okay. In complex systems like those required for game development, it is unlikely that each job is self-contained. One job is usually preparing the data for the next job. The way I think about the task we have at hand, that we're gonna multi-thread, I think it's self-contained, but we'll see. Yeah, so race condition. Like, once again, I don't think this will be too much of a problem for us. Or actually, let's see here. Might have to keep it in mind, actually. I'm wondering here. So, like, so for our algorithm, we're basically using 3 textures, one could say, or we're using 3 texture channels, and water previous, and water temporary. Water temporary is the one we use. That's where we actually calculate stuff, and then we move it to water or water previous based on how we want to visualize it. I don't know if there will be a case where something affects those channels outside of the fluid solver process, but we'll see. Native container, that's what we're gonna work with, I think. I just need to double check. Terrain data container, yeah, native array. Like, I would say that this is a pretty, should be pretty straightforward, but I'm probably gonna regret that. Because as of now, we don't want we don't want to overcomplicate this. One could think that we could do this spread in a multi-threaded way, but like I just want one separate thread entering here and doing this, iterating through this method in a linear fashion. But at certain points I want the result we have to be available to the outside, possibly. Okay. So in Unity, iJob is... Do we want to work with iJob or do we want to work with Unity jobs versus C# threading? Modding Minecraft live Google Sheets, hell yeah. I had to walk away from my cat. Hopefully nothing serious. Lost 5 minutes. Yeah, we're just looking into Unity jobs versus just straight up using C# threads for this task. Might be good to have eventually. I'm one of those crazy cat guys. I know a few of those. Job systems are optimized to SimLift. I don't know if... I don't know. It's my understanding that there's more than one crazy cat guy in this world. And hopefully I'm correct. I compared both for speed a while ago and threads were faster in my particular scenario without burst. It feels like once again, I'm just like spitballing here. It feels like the use case for threading in this case is one-off, if not the simplest threading scenario you can have, like the initial way we want to implement that is like we just have a lot of work that I need to be done in linear fashion by one thread. Okay, maybe this video will tell me more why, or will convince me why I should rely on jobs instead of just plain threads in C#. Yeah, but threading is the solution. Yes, indeed. But like, I'm just trying, when I read all of these things, I'm just trying to see how they relate to my case. So for instance, race conditions and deadlocking and stuff like that, I don't think they are things we need to worry about, which makes this way simpler. Two thoughts on jobs and multi-threading. How to not interlock. Yes. So what we're working with the most is that's true. Let's see. Yeah, okay, there's a few pitfalls we might need to keep in mind, actually. And that is, okay, so behind the scenes, right now, all the terrain related data are stored in X amounts of textures. Each texture is 4 channels, 8 bits per channel, and we have as many textures as we want to be able to pack the amount of data we have. The thing is, so right now this is not the best solution. We're probably going to move into a 3rd dimensional texture here, where the Z is going to be as big as much different data we need to store and alter. So right now we might actually have a case where, let's say that the player can run and add water to a point, we offload the work to a second thread, that thread will alter this texture, that thread will only alter water related channels, but the way the data is stored currently means that we might need to read, like, we can't just alter one channel because it's stored in a weird way. So with the current solution, yes, we might, if we add water to a point, we run away while this second thread does its job, and we dig somewhere else, we might get some weird race conditions. That is actually true. Yo, what's up, Fabic? And good morning, PG King. A little bit earlier today, appreciate it. I think what we're gonna do here is we're gonna be naive. We're gonna use C# threads to start this call and just see how it goes, basically. But yeah, and then we can alter it eventually. The way we call add fluid is quite ugly as well right now. Like I'm extremely close to doing some redesigning here. Because basically what we're gonna do is it's gonna be in terrain patch. Yeah, it's gonna be here. This one ugly right now, and if the terraform brush is type terrain data water, this is where we're gonna start our thread. Or one sec, we're gonna do it like this. We're gonna rename this one to maybe. We'll calculate this will be interesting. Yes, it will. So this is where we'll create our second thread. But I'm also wondering if we want to do it like this. Private. I wonder. Like, I also want to fail safe. So I don't think this will be possible gameplay wise. But for instance, when the player adds fluid to a point in the terrain, we call this method. This one will instantiate the thread, which will call this one, and there we go. But so this one creates a thread and starts it. If this one gets called during, like when we already have a thread doing work, we just want to cancel, right? I mean, here you come to the Unity job or thread thing. Yes. I think it's going to be a little bit of a back and forth. We will see what eventually matches our case the most. Like, this is something I want to learn either way, so let's do it. But like, start the thread. Well, let's see. Actually, do we have C# thread API? There is no one answer. Let's see, what do we have? What do we have? Properties. I want to see what I have to play around with. Is alive. If this thread has been started and has not terminated normally or aborted, otherwise false. Okay. But I wonder... I mean, dare I say, do what thou wilt. Yes, I love it. Magic Gnome, by the way, thank you for the follow, appreciate it. Okay, so my first question here is... so we do thread, new thread start. Okay, so my question here is if we do something like this. Let's see here. Is this using system.threading is enough, right? Yeah, we just call it a thread right now. It feels good. So first of all, if thread is equal to null, then we do thread is equal to new thread start, and here we just do calculate stable fluid state, terrain patch start, x start, y start fluid amount. Okay. Yeah, we want to do this with parameters as well, so I guess... let's see how we manage to do that. Passing data. So create new object with the variables we want to send into the thread, and have the thread method within that object. Is that so? I guess we could do something with this. Yeah, we could probably make this into a static method. Make this into a static class, which is probably what we wanted from the beginning. We just wanted to be able to alter these during runtime and do some experimentation. So terrain fluid solver static class, and then we have terrain fluid solver instance, which is actually our thread object with the calculate stable fluid state and where we set these. Although I wonder... I wonder. So I want to do... are you on a 2-hour limit today? Yes, I am, unfortunately. Summertime, you know. Probably gonna be for a couple of weeks now, unfortunately. One sec, be right back. Okay, back. You dirt. Yeah, I know. I like... It's gonna be a lot of fragmental progress for a couple of weeks now, but hey, as long as there's progress, you know. Let's see. So yeah, I'm thinking of... let's see here. We do new file, terrain fluid solver instance. I guess we're gonna do it like this. But then again, I wonder... terrain fluid solver instance. Yeah, whatever. I don't think we care about... may I ask how old you are? Yeah, you may. But I think I've already answered it. I'm 33. I'm at that age where you have to think how old you actually are. You have to remind yourself. Yeah, I know. You're at the prime. Yeah. Hopefully not. Hopefully I haven't peaked just yet. We'll see. But okay, let's move. Let's just take all of these for now. But we don't... in this one I don't think we need this one. Oh, did I forget to... let's see. What the hell? Okay, so in this instance we want public class terrain fluid solver instance, and okay, so here we want to store, we use private terrain patch. Oh yeah, that's true. We want to be using this one as well. Or not using, but namespace. And then we want to do terrain patch start terrain patch private int x start, private int y start, and private float start fluid amount. The thing with start fluid amount is, oh, can we actually do it like that as well? Logovich dev, definitely want to try that. Fabric so young and so little time to stream. During the summer, oops. Okay, so we can hold on with this one for a little bit. So what you're saying, Logovich Dev, is that we should be able to do new parameterized something like this. Let's see, C# parameterized thread start example. How big of a mess is it to work with this one instead? Parameterized thread start delegate supports only a single parameter. An array. Okay, so we're gonna go with a collection type anyway, or we could go with tuple, which is not too bad. I'm working on my own solution that isn't exactly streaming but will be live for my software. Wanna share some details? I'm intrigued. Tuple. So I wonder. I wonder if we're just going to go with the Fluid Solver instance instead. I'm a little bit... I wonder about this one, you know? Yeah. Public terrain fluid solver instance. Tuple, is that the way to say it? Beware the function that takes an object. Yes, indeed. Like, yeah, it scares me a bit. I want to keep away from that for now. Terrain patch. Yes. There we go. And then as to what methods we want to move here, we basically want to move all of them, I guess. Definitely this one. Definitely this one. Finish step, finish step. Might as well. But oof, we want to send in these as well. Yeah, we can keep a stopwatch here for now. Language dev or new thread example params. Okay, we could go the parameterized thread start way, but then we're gonna handle objects. The idea of having it this way around, so we have a terrain fluid solver, which is eventually going to be a static object, or yeah, a static class. So it's just gonna be our entry points for the threads, and then for every new fluid solver iteration we do or start, we create a new object, and that's the one that's actually threaded. I think this will work out fine. I think this is going to help us in the future as well. We're going to have some additional functionality we might want. What sucks about this one, however, is I want to get the different costs into this one. We have finding minimus cost, finding overflow costs, and fluid spread costs. We can just send them in here, keep them. But language dev, like, I appreciate it, and don't be surprised if at a later point we actually go with the parameterized thread solution. Everything is possible. Anything is possible. And I think we're gonna do... It all depends on... Do I think we're done with experimenting with these values here? Fabik, did you consider jobs burst? Like, we're just at the very beginning of this one, so we're considering everything, and we might pivot to it later. Depends on if it suits our needs. Very limited experience on my side. Am I done experimenting with these values? Let's take a look. Ten 1 0 1 1 0 0 1 0. Laven or Laven, what's up? How do you enjoy being a TCP dev? Fabric, in jobs you can define how much data is sent to the thread, at least for parallel jobs. Yeah, we might pivot to that later. It's a simple threading implementation we're looking at here. So the initial idea is to not have, like, we're just gonna have the main thread and one second thread that does a lot of heavy lifting. How's it going? Never tried game dev before. It's going pretty good. TCP development is fun. I love building upon with C and Seago. I just need to... so when we're talking about TCP, it's Transmission Control Protocol, right? I had to refresh my mind. And it's related to network development, right? It's been a while for me. It looks freaking awesome, the graphics are really nice. Thank you, appreciate it. Yeah, it's gonna look beautiful in... even more beautiful. In the next half year, hopefully. We're currently working on a Terraform system, and we want to be able to add water. And we have a fluid solver in place that calculates how the fluid will end up. And we just want to offload that work to a second thread. So we don't want to halt the main thread because we want to have a stable FPS. And yeah, that fluid solver takes its time. An open source HTTP alternative. Interesting. Feel free to share any links if you want. PG King 9, so in your creature collecting game you will have a way to change terrain. Yes. Like it's... yeah, the idea is that the player takes care of this plot of land, and I want to give the player as many options as possible to take care of the land and alter the land in such a way that it looks nice according to the player. And also, like, depending on those decisions, different creatures wants to come and live in your garden. So, like, the perfect example related to this fluid solver is if your garden has a body of water that is X big and Y deep, a certain type of creatures might want to come and visit and move in. If you don't have any water at all, some other creature might prefer your garden, and so on and so on. 11, it's still in the alpha phase. Okay, nice. Good luck with it. And the engine we're using here is Unity. I wonder if it's still one of the most popular one, especially for indie devs, or if Godot is starting to overtake it. I don't know. Yo, what's up, Derek? The water is coming along okay. Like, we're in the process of offloading the fluid solver to a second thread and including more actual gameplay. Like, we want to make adding the water a process now instead of a instant action. PG King, that's an awesome idea. Yeah, I can't take credit for it. It's my take on Viva Pinata, basically. Or Viva Pinata is my biggest inspiration, I would say. That one or Chow Garden. We're not talking about release just yet, but next year I will hopefully have a nice vertical slice of the terraforming gameplay. Eight11, appreciate it. Unfortunately, I won't be here in a few hours, but I stream pretty consistently, so hopefully we will see each other again. Fabic, you're too nice, but I appreciate it. I appreciate it. I know there's a few... Actually, now when I think about it, most of the streamers I used to watch have moved. But I think Dev Spius over on Twitch is another... he streams on YouTube as well. That's a quality Unity streamer. Okay, let's see. We should be able to get this to run on a second thread today at least. That shouldn't be any problems at all. I just wonder if I want to make terrain fluid solver. Yeah, fuck it, let's go. And we can do... Let's do this, this, this. Or actually, I wonder... Private, and I actually wanted to... Public... Do we need to do... Public... Static read only? Is that what we want to do? Or does read only imply... fuck it. We don't need this one here, or do we? PG King stream feature idea, having YouTube messages also show on Twitch. Yeah, I'm actually looking into that right now. I'm when I have the time, I'm experimenting with the Twitch API and the YouTube API, because believe me, I do want to have both the Twitch and YouTube chat show up on my stream, and I also want to bake in like follows, subscriptions and such in the chat. So believe me, I'm working on it. Hopefully I will have it done next month, so it will be a little bit easier to follow along. And I know there exists a couple of third-party solutions for what I want to achieve, but they don't have the visual customizability that I want. And second of all, I don't want to give any third-party sites access to my accounts, basically. I already have some given third-party access to some of my things on Twitch, but I don't want to do it with my YouTube channel, so that's why I'm looking into my own solution. And Fabric and we're gonna do a to-do list, and we're gonna have boo icons, and we're gonna have sea monkeys as well. Yeah, third-party access. It's basically you give them access to your Twitch account and YouTube account, and they usually state exactly what things they want to have access to. And some of those things are okay, like reading chat or comments, but most third-party solutions for what I want to achieve, they want a bit more, and I don't want to give up my YouTube account, basically. Yeah, clip it, Fabric, and hold me accountable. Yo, what's up, Norin Dev? So hopefully in a couple of months it will be way easier to follow both chats, independent on which platform you're looking at the stream on. Yeah. Yeah, that is true. Do I want to go with a global variable here? This one worries me. We could go the unsafe way for now. So we skip this one. We do it like this. And then of course we want to do terrain fluid solver instance is equal to new terrain fluid instance, and we want to send in this one, this one, this one, and this one. And is it like this we want to do it then? Yeah. Oh. And then we have these. I wonder. Is this the way I want to do it? So then it would basically be terrain fluid solver dot. Lagovich, goodbye. I'm going back to developing my own engine in C++. Good luck, and thank you for stopping by. Appreciate it. I'm set to record some videos on my software, right? But there's what you can and what you should and all that stuff. Elaborate. I'm interested. And don't worry about deceasing my stream. You're not. Fuck, is this how we want to do it? Terrain. For now it might be. Yeah, we have this method now. We create a terrain fluid solver instance. We create a new thread and we start that shit. The only difference now should be that we should be able to add water at a point and run around while it calculates the next stable state. But yeah, we want to change terrain patch as well. Add fluid, probably want to rename this one. Do we have terrain or environment controller? Okay, first thread related runtime error. Let's take a look at this and see what I've misunderstood. Is readable can only be called from main thread. Okay, so we're talking about, is it a texture problem? I think it might be terrain data container 77. Yeah. We don't care about the GPU at this point, we're only working with it on the CPU. Although, actually, let's see, I need to double check. If it could be the case that it's this one that screws us over, because here we do apply, so we actually we want to apply the texture to the GPU side of things as well, because we want to render the new visuals of the water while still continuing this fluid solver. If I'm not mistaken, you can only read texture in the main thread. Yeah, that is probably true. Or that seems to be the case. If that's the case, we're fucked. Or I'm fucked. Terrain fluid solver instance 33. Yeah. So I mean, it's not... Could you actually read texture with jobs? So if I go with C# threading, I can't read textures, but if I go with jobs, is it possible then? Unity read and write texture from job. Okay, this. Yeah, so like one solution would definitely be to copy the current state of the texture, but we get it in a way, and we represent it in such a way that we can work with it on a second thread, and then we have to attach it back to the textures in the end. Like depending on this one, would love to know if we would utilize this one. We're not gonna be able to run this one on a few different platforms, I guess, and that sucks. Because the fact is, this is a little bit of a roadblock. Okay. Here, get raw texture data to get a pointer to memory to fill and pass this to your worker thread. if it's easier doing it wrong. I like that saying, I like it. Clear data, so we can't... Get data array. So is this saying that we need to do get data array, get the data array, and send that data to the thread? This sucks for multiple reasons. Like, the terrain is eventually multiple patches, and each patch holds its own terrain texture. When we start adding water at a certain point, we don't know for how far it will stretch, so we don't know how many of those textures we need to send. And I'm totally fine with not being able to alter the texture data on the thread, but reading it shouldn't be a problem. Okay. Yeah, it's risky. But, like, okay, I could definitely go with the copy the data approach. But once again, like, I would like to be able to read... I would like to be able to read texture 2D data on a thread. Like, I don't have to be able to alter it, I just want to be able to read it. Having to call apply, yeah, apply we... So, like, what I'm getting at is... Ah, fuck. Yeah, this definitely makes it a bit more complicated. And we're not using it, you should use texture. Oh, I already have this one stored. Fuck, it's bright. The request into native array and request into native slice methods async. Is this what we can rely on? Interesting. Unity texture 2D. Do we have them here? Request. Or I don't care about reading from the GPU. I know that we have the fresh data on the CPU, so I don't want to get the GPU mixed up in this right now. Your Chrome tabs look so much like mine, searching for many things and not closing in case I need to check it again. Yeah, that's usually how it goes, right? Okay, so I don't care about this one. Async GPU. Fuck, reading. Okay, so we have a texture 2D, or we have a texture object. We have it on the. We have it as a texture 2D object. I just want to get. I just want to read from it and get mutable copies, right? So I would be fine with doing deep copies of it, but I want to do it on the thread. So I want the thread to be able to create a deep copy of the content of the texture. And then we can alter it how we want, and when that is done, we can feed it back to the main thread that can apply it on the texture. But I wonder if this is even possible. At least for a very newbie dev like me, I keep needing to check things. I think it's true for most of us, independent on experience. Do we have? Okay. You can get okay, yeah. So we can get the native array and then we can feed that to the job or thread and we can alter it. But I don't know how many of those native arrays I need. Fuck. Okay, nothing is set in stone at this point, so let me just paint a picture. So we might have a terrain that is, I don't know, 100 times 100 meters in the dimensions. But this terrain is just not one object, it's actually multiple terrain patches. I don't know, 4 times 4 or even more. And what I don't want to do when we add water So let's say that we can't read texture 2D data, so the underlying data for terrain patches, which means that if we want to do it on a thread, we would have to create copies of all of the data stored in all of these terrain patches, and then send them to the thread. And I don't want to do that because most of the time the water won't spread to all terrain patches, so a lot of them are going to be completely untouched. But it seems to be a little bit of a problem to even read texture 2D data on a thread. So I don't know if we can overcome that or not. Reading texture data solved. Okay. Ah, beautiful. Fabric, time to get rid of texture 2D and switch to byte. Yep. Seems to be. I'm just wondering. Graphics, Blit, Unity. We're probably gonna have to do something like that. But been there, done that. Fuck, I want to make sure, I want to make 100% sure that this is what we have to do before I take a big decisions like that. I need to map out the pros and cons, what we get from texture 2D. Fucking hell. It shouldn't be too much of a change. I think Blit is the biggest. Blit. Unity, Blit from byte array off the main thread. Graphics, copy texture. Texture source, texture. But fuck it, can we do... Where do we have the constructor? You can block copy from array. Yeah, okay. Yep. Load raw texture data. Yeah, fuck yeah. Okay. I just wonder. Okay, let's assume that we switch our backend, or like for our terrain data container, we switch from using texture 2Ds as the data holders to custom byte arrays, basically. But we still need, like, this information. We don't only need it on the CPU, we also need it on the GPU. Like, we send this data down to a lot of shaders, and I just wonder, does this mean that we're gonna end up with byte arrays that holds the actual data and which we alter, and then when we want to use it on the GPU, we need to put it into a texture 2D. Like, are we gonna end up with a lot of copy? Are we gonna end up with a lot of duplicated data, basically, if we would go with this approach? Okay, feels like I need to do some research here. Threading and textures, even just reading textures, not so good. Yo, what's up, Laven? Okay. Unfortunately, I have to run now, but okay, let's see here. Texture and threading. It comes with a few problems. I need to research and see how we can get around these. Representing the data at the back as texture 2Ds is extremely nice in some cases, but unusable in some other ways. The GPU always has to use texture data as data. Yeah, we will see about that. I need to research this and get back at it, but unfortunately I don't have much more time today. Appreciate all the input, helps a lot, but I gotta run. So thank you so much for watching, everybody, and have a great rest of the day. As for tomorrow's stream, I don't know if I can do it just yet, but I will keep you posted on my Discord. And I'm sorry. Peace.